Hi, I'm Professor Melko, Chemistry PhD, and your University Chemistry Professor. And it's time for another edition of Practice Problem Time! Let's get started. So we're going to start here. Which of the following liquids will not dissolve in ethanol? Okay, if you haven't watched my video on solutions, please go back and watch it now, and then come to this video and try to work through each of these yourself, pausing the video before I solve it. So start here. Which of the following liquids will not dissolve in ethanol? Now, I give this table in my lecture of polar solvents and non-polar solvents. Obviously, there's a lot more than just these, but these are some common ones. And the like dissolves like rule describes what will dissolve in ethanol and mix with it and what won't. So if ethanol is right here a polar solvent, then all the other polar solvents will dissolve in it, including water, acetone, and methanol. So A, B, and C will all dissolve in ethanol. A non-polar solvent will not, so the answer here has to be the one non-polar solvent there is, chloroform. That's basically the like dissolves like rule. Now, we've also talked about how to express concentration in solutions, whether that's mass percent or molarity. So let's get some practice with each of those problems. Here I dissolve 10 grams of calcium chloride in 240 grams of water. What is the mass percent calcium chloride in solution? Percent here is always going to have a familiar type of formula. It's going to be one thing over total. So if I want mass percent of calcium chloride, I need the mass of calcium chloride over the total mass. And don't just put 240 here. Include the 10. Okay? In other words, the total mass here should be of the whole solution, the calcium chloride plus the water. So 250 total. Okay? So 10 divided by 250 times 100, you should get 4.00%. So this is a 4% calcium chloride solution by mass. That's mass percent. We can also express concentration in molarity. And there's a couple different ways these questions can be asked, so I'm going to do a few different practice problems on molarity. First, what is the molarity of a solution made by dissolving 5 grams of glucose in enough water to make 100 milliliters of solution? Okay, so molarity, the abbreviation is capital M. There's a certain formula for this. So try to pause the video here and solve this problem by yourself. I'm going to work it out. Molarity is always moles solute over liters solution. Okay, so be careful. The numerator here is solute, the thing that there's less of. The denominator is solution, which is total. Okay, so the thing that there's less of here is glucose. You're putting a little bit of glucose in a lot of water. So we need moles of glucose. So the first thing I want to do, and as a chemist, I always want to get out of grams and put it into moles. So I'm going to convert grams of glucose to moles of glucose using the molar mass, which I don't have to look up. I'm given it for free of charge in this problem, 180.18 grams per 1 mole. Grams will cancel out. 5 divided by 180.18 will give me the moles of glucose. I get 0.02775 moles of glucose. And for now, I'm just carrying a lot of digits along in my calculator because I'm not at the final answer yet. I'm going to carry all these digits along. Okay, for molarity, I'm going to calculate this by using this moles, 0.02775 moles of glucose, divided by liters of solution. Okay, notice here that I'm given the milliliters of solution. 100 milliliters, you should be able to do the conversion, is 0.100 liters. Okay, so really it's 5 divided by 180.18 to get that moles of glucose, and then take that moles of glucose divided by 0.1, you should get 0.278 molarity. And that should be the final answer for this one. Next, what volume of 12 molar HCl contains 9.15 grams of HCl solute? So you can see this one is written very differently than the previous problem. You want to pick out the key points of information. This capital M here is molarity. So I always just like to write the formula for that out right next to the problem. Moles of solute, liters solution. Am I given any bits of information here? Well, 12.0 is the molarity overall. This molarity is equal to moles of solute, moles of HCl, okay, over liters solution. I'm looking for the volume, so I'm going to be solving for this denominator here, which means I should have enough information to get the moles of HCl. 9.15 grams of HCl. I use the molar mass. 36.46 grams per 1 mole. This converts 9.15 grams into moles, and I get 0.251 moles HCl. Okay, so this goes in the numerator up here. 12.0 equals 0.251. Should be more careful with my units here. 12.0 molar equals 0.251 moles divided by X liters, and I need to solve for this denominator. How do I do that? Multiply X liters on both sides. Now I have the liters times 12 molarity equals 0.251 moles. I can divide both sides by 12. So you can see, to solve for this denominator here, the liters is going to be 0.251, the moles, over the molarity 12.0. Okay, that's just basic algebra to solve that. So 0.251 divided by 12, I get a number like 0.0209 liters. That should be my final answer here for the volume of 12 molar HCl that contains 9.15 grams of HCl. So you can see these problems with molarity can be, written very differently, asked for different things. It still all comes back to this one formula though. Molarity is moles over liters. Okay, so whenever you encounter molarity, just write that formula down, plug in what the given information is, and solve for the one unknown. So that's two types of molarity questions. Let me show you the third type you might see. What is the mass of zinc dissolved in 200 milliliters of a 0.5 molar solution? Okay, so I see that capital M, and I just immediately write down 0.500 capital M. I know that is moles of solute. Here, that's zinc. Right, the thing actually given in the problem is the solute, zinc acetate, C2H3O2, and there's two of them, over liters solution. So this molarity I'm given, I know is a ratio of moles of this solute to liters of solution. Am I given one of these bits of information? Yes, I'm given 200 milliliters solution. Okay, that 200 milliliters converted to liters is 0.2. So I know this denominator here is 0.200 liters. The numerator is what I'm solving for. Ultimately, I want the mass, but I can already see if I can get the moles of zinc acetate, I can use the molar mass to get ultimately what's desired, the mass of zinc acetate. Again, I just write the formula for molarity, solve for what's not known, and then I'll be able to use that to get to my final answer. So 0.5 molar equals X over 0.2 liters. How do I solve for X? Multiply both sides by 0.2 liters. 0.2 liters times 0.5, that should give me 0.1 mole. And now I need the mass. Well, that's easy. 0.1 moles of zinc acetate. If I want moles to grams, well, I use the molar mass. And I'm given the molar mass in the problem, free of charge, 183.49 grams. in 1 mole. My moles will cancel, and so I should get here 18.3 grams of zinc acetate. And that should be my final answer for this problem. So notice these 3 types of molarity questions. One was just calculating the molarity given grams and liters, which I converted to moles and liters. The second type was given molarity, what is the volume? And the third type is given the molarity, what is the mass? Okay, so that's the 3 different permutations of this question you can have. You simply write the formula for molarity, plug in the things you're given, and solve for the unknown. Now, we also talked about using molarity to calculate dilutions. So here's a problem that demonstrates how to use a different formula for calculating the molarity of a solution as you dilute it. And whenever you see this dilution, I want you to think of M1V1 equals M2V2. Okay? This is always going to hold true for a dilution. The molarity that you're starting with times the volume you're starting with equals the molarity you end with times the volume you end with. So simply go through the problem and identify what each of these numbers is. 25 mils of a 12.7 molar solution. I'm going to call that V1 and M1. V for volume, M for molarity. It actually doesn't matter if I call them V2 and M2, okay, or V1 and M1. I just need to make sure that these two that are together stay together. They're both ones. So I'll call it V1 and M1. This is diluted to 0.5 liters. So this 0.5 liters is a second volume. I'm going to call it V2. What is the concentration of this second volume? So that's my second molarity. So M1 times V1, 12.7 molarity, times 25 milliliters, equals M2, that's what I'm solving for, times V2, 0.500 liters. But wait, the units of volume have to be the same here, right? I can't simply divide milliliters by liters. So I either need to change milliliters into liters or liters into milliliters. It doesn't matter what unit you pick, as long as they're both the same, they'll cancel out. So I'm going to take this 0.5 liters and convert it to milliliters. 1,000 milliliters in a liter means this 0.5 liters is actually 500 milliliters. And now I can solve for M2 by dividing both sides by 500. Or 500 milliliters to be exact. That way my milliliters will drop out. And so I'm really doing 12.7 times 25 divided by 500 should give you my final answer of 0.635 molar. That is the molarity of this diluted solution. And it goes down, that's what makes sense. As I dilute something, it gets less concentrated. It goes from 12.7 to 0.635. So that should be the final answer here. So that's just some example problems of mass percent, molarity, and dilutions, and covering the concept of like dissolves like. As always, please like this video and feel free to subscribe to my channel on YouTube, or catch me over on Twitch where I do practice problems like this every week during office hours where you can ask whatever chemistry questions you might have. That'll do it for today. See you next time.